Thank you everyone for coming. This is the office where I'm working in, and I can tell you that this is one of those meetups where it's full. So thanks for coming. Today I will talk about this fancy name, efficiency in motion, because scaling matters. And I hope you will take from it at least some tips that you can use from tomorrow, from the next week in your own setup. I'm kind of proud of this meetup as well because everything is about AI right now. Everyone forgot about OG Kubernetes. Now we can talk about it here. So briefly about me. My name is Yurii. I'm engineering manager at Kiwi, managing the platform infrastructure team here. I started my journey as a DevOps, so since then I'm evolved to where I am now. 6 years at Kiwi. Fun fact, I survived the data center on fire. It happened here at Kiwi, and we were not fully down, which is good. Before, I was also leading the community. It was GDG Cloud. It's another organization. It was back in Ukraine from Google. Briefly about Kiwi. For those who are traveling, probably know Kiwi, but we are a global travel tech company, and we are trying to build products that put travelers at the first place. Just briefly in numbers, so we are selling around 50,000 seats daily. Customers are doing like around 100 million searches per day as well, and overall you can search at kiwi.com 95% of the whole global flight content. Pretty big. To keep you a little bit aligned, what is Kiwi, how we look like in terms of infrastructure and everything, I will just like to give you a brief introduction. So in the beginning, when I joined, Kiwi was running purely in AWS. That was fun days when you can receive the page when the whole Kiwi was down, and you're just like panicking at night what actions you should take. The platform wasn't stable. We were running back then on the Rancher 1. Raise the hand who remembers Rancher 1. Yeah, legends. And then we had to take a decision to move to something more stable. There were other reasons why we also moved to GCP business as well, and data processing part. But one of those was the stable platform, and that was Kubernetes. Back in the day, GCP was the only cloud provider that was providing the managed Kubernetes. So we were moving at the same time to the new cloud, the whole new setup. At the same time, we were adopting Kubernetes, and the learning curve was steep. For the whole company, you had to, work with your developers, etc. But all in all, it worked out. And right now, we are mostly running everything in GKE. We have a couple dozens of clusters, and we also have a bare metal servers, and we use Rancher 2 to manage Kubernetes on those. Regarding observability, so Kiwis are like Datadog lovers, I can say. This is our primary observability tool. And it's used by everyone every single day, pretty much everywhere. We also have a hosted, pretty big Grafana stack, LGTM. For other use cases where Datadog, let's say, is not cost effective. And also we can use, I don't know, Google Cloud Monitoring, etc. So this is, in a nutshell, should give you at least some idea how the Kiwi looks like. In terms of size, let's say we are fully microservice company. There are hundreds and hundreds of the microservices, so it adds a little bit of complexity. So let's talk about scaling. As Danik mentioned, that you wanted to hear more about it. Well, you don't have to be a genius that this is a big thing, and it's important, especially in the cloud environment. You want to be elastic. So when traffic goes up, you want to scale up. If it goes down, you want to go down. You don't want to burn money either way. You don't want to be downtime, and you don't want to be overscaled. So if we talk about Kubernetes, as this is like part of the CNCF, and I think de facto standard right now for anything running for running your workloads. So we will be talking about horizontal scaling, not vertical scaling where you're just adding resources, but horizontal. And firstly, you need to scale your cluster, and it's done by something called cluster autoscaler. This is the component of the Kubernetes that can scale your nodes, add more or remove them. And it's done in, it's designed in the like a plugin-like architecture where many famous cloud providers having their own plugins for GCP, for AWS, for Azure, etc. And they know how to work with the Google virtual machines and so on. So if you're starting in GKE, you have it like by default. It works like a charm, I can say. Yeah. In AWS, there is like a similar thing. You will get like cluster autoscaler. If I'm mistaken, please pardon me. You can correct because I haven't been using AKS in AWS. But there is a better alternative, at least for the AWS part. It's called Carpenter. This is the open source project, which is also helping you scale your nodes in the cluster, but much more in much more intelligent way. It will basically pick up the right node type or instance type for the workloads that you're scheduling. So they are placed in the most optimized way. So if you're on the AWS and you don't using Carpenter, I recommend you to check this project. And now we are getting to the pods. So you want to scale your pods based on the load, right? And this is handled by the horizontal pod autoscaler. Horizontal pod autoscaler needs to somehow know how to scale your pods. And it communicates with the various APIs that Kubernetes provides. And we will go from top to bottom. So first one is metrics API. It's just a very simple one. It exposes CPU and memory information about your workload. So it's like the simplest way, kind of really reliable. It just works, But in case you need some more complicated cases, like I would like to scale based on some other metrics, right? You can use custom metrics API. This one works only for the workloads that are exposed inside the cluster. So if you have a pod or some deployment that is exposing, let's say, the Prometheus endpoint, you can target this endpoint to your custom metrics API. And horizontal pod autoscaler can use the metrics from that API to scale. The limitation of it is that, first of all, it's very hard to configure, like really bulky configuration. Second thing, it's not that practical because most of the time our observability tools and metrics, they are outside of the cluster. And here comes the external metrics API, which pretty much solves this problem. You can connect to something that is outside of your cluster. Datadog or anything else. In our case, it's Datadog. The limitation of the external metrics API is that you can connect only one provider or one endpoint. So you cannot have multiple. It will be only one. And when we moved to GCP, we obviously wanted to have a scalable infrastructure and don't receive this like mad pages pages during the night when everything is down because something is not scaling. So we started exploring what is there, and the only available option to us was the external Datadog external metrics provider. It was massive improvement to our autoscaling because before we were not able to scale based on the external metrics. And when we saw that actually the system can scale based on what we are, let's say, producing, like queues, etc., it was a huge relief, massive improvement. And on the right side, you can see how it was, how the configuration was done. You just deployed the Datadog external metrics provider part, which was one for cluster, and then everyone was able to just specify some kind of external metric from Datadog, specify the query. And it was working. It was really great. It had some hiccups. For example, if you specify the wrong query, obviously you couldn't scale because such query or metric doesn't exist. You made a typo. But the problem was that it was breaking also all other scaling in the cluster. So if someone deployed the wrong HPA with the wrong query, it would break all other HPAs fetching like the information from the Datadog. So somehow it wasn't handled very well on the Datadog external provider side, or like HPA, something wasn't clicking that well. But it was working. We didn't have like that many cases. It was working just fine. Yeah, here you can see like a zoom in how the configuration was done, like really simple, primitive, was just working. And it was working until 8th of March last year. Anyone knows what happened 8th of March last year? Specifically at 7:57 a.m. Related to the Datadog? Datadog went down. The price goes to? No, really, what's your name? Kostya. Well done, Kostya. Yes, Datadog was down. I bet Kostya uses Datadog at work. So what happens when your main observability like system or tool is down? You kind of go through various stages. Like, so first one, everything is good, right? Because, well, you don't see alerts, you know, everything is fine, you're just like doing your coding. Then the mild panic kicks in when you're coming to the realization that like, oh my God, you know, like we lost visibility in the huge complex system. You have no idea what to expect. And then just like praying, you know, just like, please don't collapse. So how exactly did it affect us? Well, for 12 hours, that was the time of the Datadog outage, we lost the visibility into our like system. Nothing was working. Dashboards not working, metrics not working, alerts not working. Well, scaling is not working. There is like a huge postmortem by Datadog. You can also Google it. So what helped us actually if we lost like such a visibility in the system? We were lucky because one of the senior management managers, yeah, they detected in some old analytical dashboard that the booking count is just going down. And we were lucky because like it was a legacy system, just booking application was configured long time ago to send metrics to Datadog, and the same metrics about bookings to that system that was using that dashboard. So we somehow like were like notified by this. Well, this is where the panic started. So we were like, oh my God, we don't have really any visibility. Problems are here and there. Queues are rising. You know, we don't know what to do. And what is happening then? You're becoming double reactive. You're like, oh, should I touch this? No. Should I touch this? Oh my God, did we remind? We forgot about that service. It's also important, and so on. And you don't know what to do. And the paradox is in that situation, if you just don't scale, you lose money. But if you scale recklessly, you lose even more. Because scaling manually in the complex microservice system is really hard. Like you don't want to scale one service which will overload another service. So you need to know which one goes after which one, and you need to scale like one by one slowly. And this is where the Kiwi and the whole, let's say, the engineering was shining, I would say, because we had, I remember the day, like we hopped in on the like a huge Zoom call. There were like people like from the whole teams, each team in the engineering, and we were like slowly coordinating like which steps to take and how to scale. So yeah, it kind of forced us, you know, to think about like how we can mitigate it. And well, the obvious things will be like, we would like to scale on something maybe else, you know, not just Datadog, but have some alternative source of metrics. And just a reminder, external metrics API has this limitation that you have only one external metric provider, and well, Datadog was down. And another mitigation step can be, it would be good if something is down, Datadog in this case, we would like to fall back to some default values. So we are like not extremely overscaled, not downscaled, but we are able like just to survive like a regular, let's say, load. And I hope I will not steal too much from the next speaker, but I will briefly mention about KEDA, because that was our story pretty much to start using KEDA. Briefly, it's a Kubernetes event-driven autoscaling. This is the open source. Let's start with this. Who is using KEDA? 1/3. Okay. So maybe for you guys who don't use, it will be like really, really helpful. It's open source project. You're also part of the CNCF, actually graduated. So really reliable, mature. It supports like more than 50 different scalers. So you can use different providers, not just Datadog, like CloudWatch, I don't know, Grafana, etc. It has this magic that you can scale to 0. If you know, in Kubernetes, you can scale minimum to 1. But with KEDA, you can scale to 0, which you can do some creative tricks with it, save money. There is like amazing flexibility in terms of authentication. You can authenticate to the providers using, for example, workload identity, you know, not using passwords, etc., JWT authentication, etc. So no pure like API keys somewhere and so on. You can have fallback values there. You can even post scaling just with some annotation, and you can even scale your jobs. We don't use it, but in case you use Kubernetes jobs for some batch processing, you can define the size of that, like of how many jobs like will spawn using KEDA. And this is just a diagram how it works. So it's just a middleware between all the providers that are out there, Datadog, CloudWatch, Grafana, Prometheus, Kafka, whatever, you name it. And underneath it, how you interact with KEDA, you just use scaled, so-called scaled object resource. You don't operate with the horizontal pod with the HPA, but you operate with the scaled object, which respectively operates HPA for you. So I will just walk you through the example how we were configuring it before KEDA, and then how we did it with KEDA. So for Datadog, we had to create before a separate resource, which was referring some metric, doing the query. Then you had to create the separate horizontal. I hope you can see it well. If no, don't worry. We had to create a separate horizontal pod of the autoscaler resource, reference this metric from there. And in KEDA, it was simply the same, just like one file, and you were able to refer it in Datadog. For Datadog. This is just a zoom in, and here you can see like some cool features. You can have like a fallback value after some failure threshold, and well, you can define trigger, one or many. In this case, we use Datadog, but later then we started using also combinations like Datadog CPU plus I don't know, metric from the cloud monitoring. So, and it will like pick the right value depending on all these 3 evaluations, like how to scale. The important part for us was like how to switch everything, or like the most important teams to use KEDA, because Kiwi is big. We really like the engineering size is around like 400 or 500 people. We have even more microservices, and you need to somehow like provide them tooling like to easily switch to KEDA. And what we did, we just did a simple you know, templater tool like CLI, you can say, where developers would just target their HPA and it will convert it automatically to the scaled object, and they can apply and start using it. So we didn't want to impact developer experience. The teams that were affected by the Datadog outage really wanted to do it, but we wanted to provide them to do the switch efficiently. Authentication flexibility I already mentioned. Developers were really happy because there were use cases where, for example, you want to scale based on some GCP metrics, which appear in GCP quite fast. But if you source them to Datadog, there is like a 10-minute you know, gap before they appear. So some teams wanted to combine all that. Before we couldn't do this, now we can. Fallback value, another like a very useful tool. All the teams that were impacted, especially critical services, have this value set it up. I would recommend something in between min and max that you have specified there, so you're not fully overscaled and you don't burn money in case you did some mistake, and you're not running on the low values. So something in the middle ground would work. Well, and scaling to 0, it's like magical thing. So we did some tries before. So if you would be able somehow automate this thing, you can save like, let's say 30% of the cost on your dev environment or sandbox environment, where you would just scale it down during weekend or at night. So in the end, we took a little bit different approach, where we decided why to scale only during weekend. Let's run on the low resources the whole week. Yeah, so, but I use this approach personally to have the cloud run like deployment in Kubernetes. So we have Istio in some clusters, and Istio produces like metrics, everything that you're sending it, like trying to query your service. And eventually you would see this metrics in Datadog, let's say, or in Grafana. And by default, I have set it up, the scaler to scale to 0 if there are no metrics. So my deployment is scaled to 0, test deployment. And whenever I need to test something, I just like send queries to my endpoint, whatever API, skypicker.com or something like this, or kiwi.com. And the KEDA will notice that there are incoming requests to my endpoint, even though they're failing, but it will detect there is something incoming, and it will scale up my deployment eventually. So there is this cold start, which I don't mind, because this is like either for the sandbox or dev environment. But you know, like I don't have to care, like, oh, I forgot to scale down. I don't burn money. It's just running like this. So just you can use this tip maybe to somehow be creative in your setup. Just checking time till when I have. Yes, okay. Okay, so this is about scaling, you know, and there is another part which is scheduling, right? So how scheduling works in Kubernetes? Well, there is this component of the control plane called kubescheduler, and its job is very simple. It's like, if there is new pod, I will assign it like to some node, you know. So it does it like very simply. But important part here is that decisions are influenced by the by its view of the Kubernetes cluster at the point when the new pod appears. So the new pod appeared, it checks like the status of the whole cluster, makes a decision, not a pod placed, okay, move on. That's it. And it's all good, but you know, what if the original scheduling decision is not valid anymore? So you put it like to some node, but then like the status of the cluster changed, your pod would be still running there. So if the scheduler would make a decision at this point of time, it would be different, you know? So for example, you're adding like new nodes or zones to your cluster, it will not force your deployment to be like somehow changed. Or like, for example, your nodes are over or underutilized and you want to somehow do something about it like automatically. And for example, yeah, you had a failure of some nodes, those pod moved somewhere else, then you brought up those nodes again to the cluster, and well, like they're still running on, like you have empty nodes. And just to better understand, I will just give you our use case, so maybe it will be useful for you. So this is the diagram of, let's say, one of the biggest clusters that we have. This is search cluster on the left. And you can see we have three zonal clusters. On the right, you can see like a huge NoSQL database. It was self-hosted, then we moved it like to the cloud. Now we are switched to the big table, but nevertheless, the use case stays there. So It's really big. I mean, the traffic that goes back and forth, so database is used to store the flight combinations, this kind of things, and the deployment is used to like serve these combinations to the users. So there is a lot of traffic passing through it, and for those, like you probably know that traffic is cross-zonal traffic is expensive. So ideally, you want to keep it like going like it's on the diagram. So it is like a tip how to achieve this like even distribution of your workload pods within like the zones. So there is something called topology spread constraint, something that you can use. It's very simple. You're just adding topology spread constraint to your deployment, specifying the value. Let's say I want to have max Q1 in the zone, and here you can see the GIF that kind of shows you how it works. So it will make sure that during scheduling, the difference between the zones is like maximum 1 pod. So it will try to place it like correctly. And you have like a good high availability, a load distribution, cost savings because of the cross-zonal traffic. And if you use also topology-aware routing in your services, it will bring it like even bigger, let's say, benefits. But we are talking about cloud, right? I mean, it's not only affecting cloud, but we are mostly GKE, so everything is in the cloud. And remember, this deployment is really big. Cluster is also huge. So money are important, so we are like running this that workload like on the spot instances, preemptible instances. I'm not sure how preemptible it's called, like right in AWS as well. But the beauty is it's cheaper, like around 70% of the original price, which is good. But the drawback is that Google can reclaim those nodes whenever they want, whenever they feel the demand for it. And usually it's like, you know, a couple of nodes here and there. It's not affecting your deployment at all. But sometimes it happens that they doing like some huge revocation in one of the zones. And by huge, I'm saying like really huge. That sometime you're receiving just these messages, you know, on Slack and alerts like, hey, what happened at the time? You know, like we see that like reads drop and increase in other zone and so on, and you're like trying to understand what the hell is going on. On the yeah, you can see request by client and availability zone, and on the other side you can see the reads in the database. So you can clearly see that something changed. And when the database was self-hosted, it's like it was really overloading some of the zones in our bare metal cluster. So if this database is down, it's really bad. It's like really, really bad. So you really want to like balance it clearly. And well, the fix is like really simple. Let's just do kubectl rollout restart. The scheduler will take everything into calculation again. New nodes were added, and we are recovered until it happens again. You know, and it's really, really annoying to do this like all the time manually. So there is, when we were looking like how we can like automate it, you know, you can come up with some solution, I don't know, like a cron job or something, some watcher, like implement something custom. But there is a project eventually for that which can do this and even more for you. It's called Descheduler. Any one of you heard about Descheduler? Some people, nice. So the purpose of it is simple. Like you need something that will care about your pods after they are scheduled, like to match your state, you know, that you wanted during scheduling. And it works also in the simple way. You just define the policy, and based on that policy, it takes the decision after the pod was scheduled. Here is like some more details, but basically it works in the principle of the plugins. There is some plugin that is making the decision, you know, before, based on some parameters that you specified in labels. And there are like 2 strategy plugins. That one is, you know, that will take a decision just like pod by pod. So for example, okay, I'm checking this pod. If it's like satisfying my policy constraints, or it's not satisfying, okay, removing, you know, and it will go then again to another pod, etc. And there is another one, I think it's called, in this case, balance. Yeah, balance enabled. it will evaluate the whole state of your deployment. So it will take like all the pods from this deployment, do the calculation and math, and then it will take a decision. I need to evict, I don't know, 10 pods at the same time because they need to be moved to the different region or zone. So this is exactly the scheduler in action. So there was some inefficient, let's say, scaling. Some events happened, and then the scheduler is making decision based on your policy, and in the end you have everything balanced. If this is not your use case, you can use it like for something else. For example, for the efficient resource utilization on your nodes. So you can say like, I want my nodes to be highly utilized, and it will just start, let's say, evicting it, like shuffling it all together. It can work, it can be as a complementary tool to the GKE autoscaling to make a decision, let's say, faster if you need it. Maybe GKE is not the best case right now because you can have like different autoscaling profiles in the Kubernetes cluster, but if you're using running your Kubernetes somewhere else, it can work. Or it can work other way around when you want to have like an even distribution of the workload. So we had this, for example, in our hosted, self-hosted bare metal Kubernetes servers. Provider was doing something, with the servers, rack was down or something like this. So the nodes went down, the pods were rescheduled, then the nodes were back after maintenance. And well, now you need to reschedule all the pods again, like on those nodes, because they don't have any workloads, and you're eventually overheating some, other servers. So it can like balance it for you automatically. Or another use case for us. So back in GKE like 1.21, like lower version, there was like a bug with the preemptible nodes or spot instances when the node was going down. But it somehow wasn't properly cleaning up the pods. So the pod was stuck in the termination state, or this like shutdown state, and it was just like, piling up. So when you do like kubectl get pods, you can see like, oh my God, this list of pods, why they are not removed. So you either do this like then manually, or it can do it for you, removing the failed pods with that failed pods plugin. Well, and now I want to say this phrase, in the world of computing, efficiency is the king, but the truth is efficiently learning from your mistake is a king. Because no matter how much I talk about KEDA, the schedule, etc., you still can end up in this state. This is the screenshot from today, by the way. When you have, like unbalanced instances. And in this case, to be fair, it's not the problem of our KEDA or like a wrong configuration of the deployments. That was simple mistake that we didn't click like a balanced scheduling on the GKE configuration. So it was just spawning nodes where it could. So yeah, thank you so much for listening. I hope you will take at least something from this talk that you can practically implement at your work the next days. Thank you. If you have any questions, anything, I will be here around, so feel free to talk to me.
Okay, let's start with Slido. First question is, how will you configure topology constraints for long-lived collections?
I'm not sure I understand the question. So topology, is anyone here like us, like can maybe elaborate?
Yeah, give me a second.
I was writing this, I just wanted to ask, like, for example,
Second, please.
if you have
Please.
I can just kind
So, if you have like, I don't know, some file transfer traffic where you have like big files, so it's with slow internet connection from the other side. Yes, you need, I don't know, you could have like one node overscaled just because you need to wait for all the requests to finish before shutting down the pod and rescheduling into the another node. and how you will like configure topology constraint just to like maybe kill some requests because like it's really like overloaded node.
What's your name? Artem. Thanks for your question, Artem. I think topology constraints has nothing to do with it. Like topology constraints is just like helping you to schedule your pods according to some constraints. Let's say you want to have it like pods spread across the nodes, so you don't want like 2 pods of the same, or like 3 pods of your deployment run on the same node. So you would use it, it will like spread it accordingly. Or you can do this like cross zone and so on. So the decision with the topology constraint is taken like when you're scheduling your pod. So when the pod is running, topology constraint, it has nothing to do with it. Something that you can use in this case, for example, to prevent your pod to be like shut down like in the middle when it's doing like the transfer, you can use like a progress deadline seconds. By default it's 5 minutes, if I'm not mistaken, like 300 seconds. And you can increase this value up to 1 hour, if I'm not mistaken. Yeah, and if 1 hour, let's say, is enough for you, for your workload to finish this like file transfer or something, that can work. So the Kubernetes will wait, will not shut down your pod until this time is passed, or when your pod will be down. Another trick that you can use, you can implement. So when the progress deadline seconds finishes, it sends like a SIG term to your. It sends a SIG term to your application actually before you turning down the pod. So your pod knows that it has to go down. It gives like time to finish, and then it shuts it down. If the deadline seconds is longer, it will like force shut it down. But you can also implement some like internal logic. So I don't know, and use the live stop hook in your deployment. So for example, when your pod goes down, this live stop container live stop hook will be executed. And for example, you can call some endpoint on your application, like, I don't know, terminate or like save progress of the file transfer, something like this. And your application would know like, okay, now I will be shut it down. So I need to take this implementation, I don't know, cut off like it in half and send the second half later somehow. So you need to work with this like saving the state and so on. But yeah, topology spread constraint is not like part of this.
Okay, second question. Do we need the scheduler if we're using Carpenter, which evicts nodes?
Like I mentioned before, maybe no, because I haven't used Carpenter. We are running fully in GCP, and Carpenter is available only for the AWS. So maybe this, I said, Carpenter is very intelligent service, so it can like figure out like what is better. So if it's doing like calculations periodically when cluster is in a certain state, and it can say that like, okay, I can collocate this 10 pods on 1 node instead of like 3 nodes, because it will be more efficient in terms of costs because of like CPU and collocation. It will do it for you. So maybe with Carpenter you don't need the scheduler.
When Datadog went down, did everything scale down to a minute of the HPA, or stayed frozen at the last desired replica count?
Yes, very good question. Second, so it stayed with the frozen last desired count. This is how it works, horizontal pod autoscaler. If it's not able to fetch any metrics, or it's broken or something like this, it just leaves your deployment with the replicas at that state when it was broken. In our case, it was not enough, because the traffic goes like up and down. So in the morning it's like really low, and then it's like starts to pile up, because during the day people search more, book more, etc. And we stuck in the state when we were like kind of on the lower numbers, and when the traffic started to pile up, we really had to scale up at that time. But well, we were close to minimum.
What about HTTP-based traffic? Don't you see delay in Datadog metric due to scraping, and also scale to 0 issue?
Actually, there are I wouldn't say there are problems with Datadog in terms of delay. It works quite well. It depends on your polling. I would say the bigger issue is the misconfiguration. So for example, you're sending your metrics every minute, right? So your metric is popping up every minute, but then your default poll from the schedule, like scaled object, is like every 15 seconds, right? So it will try to fetch the metric, but it's still not there because you're sending the new one every minute. So it will say like, oh, I cannot fetch metric, I cannot fetch metric, cannot fetch metric, until there will be like 1 minute, new one appear. So that would be like a most common, let's say, problem that we have. You need to be aware about it. Delays, no, there are no delays. Fun fact that even up until 3 weeks ago, we were using Datadog in US side. Recently, we did like a huge migration, full Datadog from US to EU. But even with the Datadog being in US and we have been polling metrics from the US side from Datadog, we didn't see like delays or any problems. The bigger issue that you can hit here with Datadog while using KEDA is rate limits. If your system is really big, like in our case, and you're using a lot of like HPAs, like scaled object and Datadog, it will be like really hammering Datadog API. And Datadog has like a strict limits on the API, so you can be rate limited, and it can be like a bottleneck for you to scale. Two options here. First one, you can ask Datadog to increase the rate limits. They will say, no, we don't, but they do. If you ask politely. Huh? Yeah, that's also true. I mean, if you're a big customer, they obviously have an interest for you using like Datadog in full, and if you emphasize that this is critical for you, they will increase it. Like the recent, again, use case, so we had increased certain like rate limit on the Datadog API when we were in the US side, but we recently migrated to the EU, and they didn't increase it like to the same values. And we were hitting these problems just like recent weeks, like that KEDA was rate limited. Another option is in the newest KEDA version, which was released basically 1 month ago, you can, they wrote a new, let's say, scaler that will pull the metrics not directly from the Datadog API, but will use the Datadog cluster agent. For those who run Datadog, you probably know. So it will use Datadog agent as a proxy to fetch the metrics, and it is doing like in the more intelligent way, because they rely on the Datadog cluster agent itself to somehow like cache the metrics, or I don't know, like do some magic, like so you're not hammering the Datadog API that like fearlessly. Yeah, scaling to 0. Well, we don't scale to 0 right now, just on this like playing project.
How do you achieve the topology error routing? Is still destination rules or something better?
Both. So we started. How many of you use Istio, like in production? 1, 2 hands. So Istio is like generally hard. Right now we actually switched like half of the company already, more than the half of the company like to use Istio. So up until some version of Kubernetes, Kubernetes natively didn't support any topology aware routing in services. You were not able to configure it. It was just like round robin, like randomly sending requests. The only way there was to use Istio, and that was one of the reasons why our search team was the first one to implement, let's say, Istio, and we were using, yes, destination rules, if I'm not mistaken, to have like a topology-aware routing. In the next versions of the Kubernetes, I think it was public, like fully released in 1.27 or something like this, or 26. That Kubernetes added topology-aware routing to the service itself. So Kubernetes service, you can specify the topology-aware routing. So whenever someone will be calling your requesting service, it would check like the topology-aware, like your labels, like zones, and try to route. There are some recommendations when to use it. So if your deployment, for example, doesn't have at least 9 pods, which you have like 3 pods, let's say, per zone, it's not recommended. The topology of our routing can do some mistakes or miscalculations, so you can expect it. So it's recommended for the services that are running at least 9 pods, for example. It's simple. It works.
You mentioned about scaling based on external metrics using Datadog external metric provider. But what about usage of Prometheus as alternative?
Thank you for the question. I just want to clarify Prometheus adapter. Is it meant like as part of, from the KEDA, like part of the KEDA trigger, or do you mean it as part of the custom metrics API? Yeah. So. Prometheus adapter is like part of the Prometheus project, right? And you can like deploy it in your cluster and expose the metrics, Prometheus metrics inside the cluster, and then connect it like to the metrics API, external metrics API or custom metrics API, and use it like this. This is valid option, that's true, but we are not using Prometheus that much. We were using Datadog mostly, so that was like the obvious choice for us. Yeah, in this case, I can bet that Prometheus adapter configuration is much more complex. It's like really bulky. I might be wrong, so okay, I will not put my statement on it. Yeah, okay. You want to?
So the Prometheus adapter is using the custom metrics endpoint, which is the different and the Datadog. And also, it's the same case like with the Datadog. So basically, no, it's already fast. Okay, sorry for that, guys. So once again, so basically the Prometheus adapter is using custom metrics provider, which is different than the Datadog one. And it has the same issue like the Datadog. So basically the configuration is shared across all deployments. It's like a single config map. So it's kind of tricky. And the downside is basically you can use only Prometheus metrics. And basically I know that a lot of companies are not starting, to stop using this kind of approach.
Yep. But you can use it obviously, but you will hit the same limitations as with Datadog.